Okay. Um, okay, so with reference to homework, um, you need to know that I've spent a lot of time over the last 15 years trying to reduce the amount of homework. I totally understand that if I give you a huge amount, yeah, you get lots of practice, but having lived through the years you are now living through, and having had 5 children of my own live through, you know, junior, senior year in high school, I want to try and reduce the homework as much as I can and still make sure we have a very high level of success. And I feel like prior to COVID complicating everything, we had that dialed in pretty good. I think I showed you the numbers that the year before COVID, I had 202 students take the AP test, all but like 13 of them passed, something like that. That was a very high number, okay? Maybe a little more than that. It was 91%. But anyway, I've tried to reduce the homework significantly. So even though it may feel like a lot at times, it really has been reduced about as much as I dare reduce it. Therefore, it is not helpful to do part of the homework. Okay, you need to treat each homework like a miniature test. And if you do 75% of it, you're kind of preparing to get about a 60 out of 100 on the test because you'll be missing key ideas that I'm trying to test you on in the homework. Okay, the homework is like a small test. You're trying to verify that things make sense, that you can really recall what we've been discussing. Okay, so I don't ever ask for partial completion on the homework. I just ask you to tell me, did you get through everything? Did you finish every problem? Did you look at every answer? Did you feel confident that as far as you can tell, you are on the right track? Like you're really making sense of what we're discussing. Questions about that? Okay, so what I do this morning is I'm going to walk up to each of you. I want to give an on-time award as well today, just to keep encouraging everyone to be here on time. So I think everyone in the room here was on time. I don't recall anybody walking in late. So, sorry, there we go. One, my bad. Anyway, when I walk up to your desk, if you were on time and you finished the homework assignment completely, feeling really good about it, you give me 3, I'll give you 3 tickets. So you just show me 3. If you were on time but you really have not adequately finished the homework, you give me 1. And I'll give you the on-time ticket but not the homework tickets, okay? If you still want to get some extra credit for the homework, if you stay after school, like soon, or you come early soon, like the next day or two, and you get your questions answered, if you have questions, or you come back and tell me face to face, hey, I wasn't done when we got to class, but I've caught right up, I can still give you like half of the extra credit, like to keep you on pace for, not falling behind. Questions? So you're going to give me this if you were just on time, no homework, this if you're on time and homework, this if you walked in a little bit late, but you did have the homework done. So show me. I'll practice names here. Marielle Sutton. There we go. Paisley Barlow. Katie Rands. Maddie Hunt. Anna Hunt. We just established with 2 N's. So, okay. Taryn Marriott. Good job, Taryn. Queston, well done. There we go. Harrison Pope. Riley Barrett. 2 R's, 2 T's. Rachel Jemmett. Double everything except for the J. Sweet. Chris Billings. Nicely done. Dallin Larson. You asked Camilla about the song yet? That's okay. Just curious. I'll keep asking it because I'm very curious now. So I'll probably be like, my hopes will be all dashed. Like it's a totally different student. I'm not even thinking of the right one. But there we go. Nice job. Sorry, John. There we go. Luke Hayes. Amelia Erickson. Nicely done. Good work. Hannah Bartholomew. Yeah, sorry. Good work. Isaac Irwin. Good job. Soraya Hoover. Finally got it. There you go. Good job, Soraya. Don't say it. Shoot. Don't say it. Nate Ashton. There we go. But no Ashtons I know. Okay. Haley Pedroza. Said with a bad accent. Lillian Glass. Dang. Extra. Ruth Glass. Name penalty. Caitlin Carroll. Kate Spencer. Yeah, that's where I get mixed up. Because you are Catherine, but you go by Kate. There's a Catherine Bybee. She goes by Katie. She sits right there in a different period, so that's what's messing me up. Grace Coford. Kate as well. Spencer. I don't know. Crofts, extra for the name. Good job, Julian Wispin. Well done. So, unfortunately, no, just because calculus just goes too fast. So, yeah, that's where you just want to come in as quick as you can before after school, and we can talk about it. So, yeah. Once in a while, maybe, but it's really hard to keep on pace. Yeah. No, thank you. Okay, I'm handing you this pink packet. You're not going to do anything in the pink yet, but I just want to get it into your hands. So, there's two there. There's two of them. That might be three. There we go. Thank you, Stride. Here we go. That's perfect. Thank you. There's three of them there. So I hand one to Grace, Kate Crofts. Okay, look up. Look at me. Okay, look up. Make sure your phone is put away now, so don't get it out anymore. My experience has been that even though students think they can glance at their phone, it really does translate to really bad test score. I'm not exaggerating. Like just not being attentive. Like if the class seems easy right now, be a little patient. I promise it will be challenging enough. So, never had a single student ever finish AP Calculus and come to me and say, "Yeah, that was really easy. I should have took BC." You can. If you want to go take BC, you can. I'm just saying. Anyway, moving on. Okay. Don't take notes on this yet. Like, don't do anything on this. So you need to have a page in your notebook to take notes. However you do that, it's up to you. I like Anna's method. I like just having the binder with note paper mixed in with my handouts. But if you like something else, that's okay. You also need to make some flashcards. So grab a flashcard. Here are the 3 flashcards you're making. So I've tried to make it fairly straightforward. The one side of the flashcard is what you see in the red, and then the other side of the flashcard is what's written below the red. So make those flashcards, please. Go. The first one seems a little non-mathematical, but I have found it to be very helpful. You need to keep straight what we mean by term versus factor. I use those words a lot. And calling something a thing isn't really mathematical, but it usually helps you and I understand it better. So when you have a term, you have a thing added to a thing. Things, when you look at something, you say, hey, these two things are adding, then you're thinking of them as being terms. You look at something and you say, hey, these two things are being multiplied, you're thinking of it as the thing being a factor. Crucial that you keep that straight. Oh, please. So I'm going to give Amelia several mentions of her name so she can keep marking down points, because I was really hoping someone would raise their hand and ask that. Like it was kind of a setup. Sometimes when two things are being multiplied, we will use parentheses to indicate that, Amelia, but not always. So I purposely left it off to indicate that, yeah, sometimes when you see two factors, they'll have parentheses, sometimes not. The same thing with terms. I've seen situations where you might have a parenthesis to indicate term, less likely with terms. It's more common with factors. Is that your question? Okay. Kind of a lot of flashcards today. But I have a bit of OCD tendencies in my personality. Some people would say more than a bit. So as soon as I handed the paper to Anne, I couldn't help but noticing that she did such a nice job of matching the color this morning. So it's very good work. So thank you. So it made me feel very good. So, oh, it's a match set. It's even better. All right. Yeah, I'm a matchy person. I'll make up work. It's really dumb. I'll make up worksheets, and I can't not make it match sometimes. I don't know. I'm like, keep telling, move on. Doesn't matter. So, no, it matters. I fix it. Okay. Awesome. We will discuss what this means as we go forward in the examples, but I wanted you to have the flashcard in your hand, so as we talk about it, you can go, okay, flashcard says this. We're now talking about it. Next thing. Okay, in the homework tonight, you will be asked to do two things on every single problem. So if you look at the pink packet I gave you, you'll notice that the instructions say, first, find the limit of each function as specified. So you'll see that instruction. Find the limit of each function as specified. But you also see that it says, also determine whether the given function has a horizontal asymptote or not. Okay? So we have to do both things on every single problem. There are only 21 of them, but you have to do both things. So today, the discussion is straightforward. We're just practicing what you're doing in the homework. But again, you should not just do what I do. You should understand why I'm doing it, okay? That came up in a class yesterday very clearly. We did an example, and then I kind of changed the example just a little bit like they do on the AP test, and right away one of the students fell into the trap. She immediately followed my pattern, not the idea, and completely got the wrong answer because she was just copying the pattern. Don't copy the pattern. So in your notes, please write what's on the board over there. This here you don't have to put in your notes because these are on your flashcards, basically. So don't write that in your notes. You're just going to reference your flashcard as we talk about it. This one's a new flashcard, though. You'll need to make this one, sorry. So create this flashcard here. The other two are basically just copies of what's on the bottom. So it should have 4 total flashcards now. Give you a second to write that down. Okay, next thing, so you've got the 4 flashcards. Now in your notes, write this. That's our first example. Write that expression in your notes. Okay, here we go. So let's move this out of the way. Okay, so again in the homework you have to do 2 things. So we're going to work on this one first. We're going to worry about finding the limit as specified. So we're going to do this first. We're going to find the limit as specified. Okay, so look at your limit flashcard. Your limit flashcard is the one that looks like this, that says finding a limit, the one you just made. We're going to follow that sequence of thoughts, finding a limit. And to make it so I can point to it, I've just recopied those exact words here. So we're on this statement right here. We are looking to see if we have x approaching positive or negative infinity. And in this example we do. So we are going to first follow this instruction. We are going to compare terms that add. So we look at the expression we are finding the limit of, and we first identify, okay, you always treat numerator and denominator separately. In this class, hardly anything where we ever combine them, so keep them separate. So you look at the numerator and you identify, are there things in the numerator that are adding? Now, addition and subtracting a negative are the same thing. So I like to look at it as, in that numerator I have really 3n cubed, and that's a positive value. That is being added to a negative 5n. So in my numerator, I have one term adding to a second term. That's the numerator. 2 terms that are being added. Questions? Now, each term does consist of factors. For example, this first term is comprised of the factor 3 multiplied by an n, another n, and another n. So when you look at the term is 3n cubed, but that term is made up of factors. That's the difference between factor versus term. Questions? Okay, so we're back to here. We are trying to find the limit as specified. Because we are doing a limit where x is approaching infinity, we are going to compare terms that add. And in the numerator, we have 2 terms that are adding. The idea of n approaching infinity is this. The value of n is going to get larger and larger and never stop getting larger. And when that happens, you're supposed to evaluate what will happen to this formula. Like, what number will that produce when n gets larger and larger and larger? Because remember, it's all about x and y, input and output. In this case, n is the input. This formula is how we calculate the y value or the output. Trying to figure out what happens to the formula when n just grows and grows and grows. Questions? Please, Taryn. Going to say your name multiple times to get lots of points here. So I love what Taryn is saying because she's remembering exactly what we've discussed to this point. That when we are finding a limit, we've got to check limit from the left and limit from the right. N approaching infinity is an exception because we're not approaching a number. Like we don't keep going and going and then finally find infinity. Infinity means n grows forever. So there's no way to go past. Does that make any sense? Correct. No, Taryn said it really well. As n's approaching infinity, there are no two sides. There's just n growing forever. You can't go to infinity and then come back. Does that make sense? Well done. Anybody else? Okay, so we know n is approaching infinity. As Taryn said, we don't have to worry about left and right. All we have to think about is this idea, comparing terms that add. So now what we say is, here's one term, here's the other. Now, interestingly, with power functions, these are both power functions, you don't really have to worry very much about positives and negatives. Here's an example why. Look over here. Look at my hands. Try to imagine. In one hand, I'm representing a debt of, let's say, 1 trillion, like negative 1 trillion. Okay, debt. That's a lot of debt. This hand represent income, like 1 million in income. That's a lot of income. But this is negative trillion. This is positive million. If I'm adding these two values together to get a total, raise your hand if you can tell me which of the two is important and which of the two is so much less important by comparison you don't hardly even notice. Hands up. When you add negative trillion to positive 1 million, which of the two values will dominate? Will be so much more significant than the other that in some cases you might be able to neglect the other. Which one? Still question? So are we neglecting the trillion or is the trillion the dominant one? No worries, I was just making sure. So how many knew that the negative trillion would be dominant? Show me your hands. Point. So as Queston said, more points for Queston, there's 2 more. It doesn't matter positive or negative really. It's like which one is, basically larger. Okay, mathematically speaking, a million's positive, a trillion's negative, so you say this is greater than this, but in a practical sense, when you add them together, the trillion still dominates. So I don't really worry about negatives. I just look at the two terms and say, well, since they're both power functions, whichever term has the higher power, that is the dominant term. And what's interesting, you'd have to use a computer to verify this, but as n gets bigger and bigger and bigger, this term becomes more and more dominant. Like you get weird things, yes, because of the exponent. You get weird things happening, like once you have digits that are, okay, try and imagine this. You put in an n that is so large, when you cube that n, you get a digit that's like 1 million digits long. Like we're talking, like n grows forever. This will become extremely large as well, but not even close to how large that becomes. So that's what we mean by compare terms that add. You're looking for something that is dominant, that you can ignore the negligible term. Questions? Okay, if we do the same thing in the bottom, we're going to identify very similarly that n cubed is dominant. So now on your paper, make sure you write it this way so you don't lose points on the AP test. You have the original problem here. You should next write equal. I'm going to try and be good on showing you this pattern where we want to do your work straight down the page using equal signs. And if there are some scratch work that we need to do, we want to do that off to the sides so the grader can see clearly you know how to communicate mathematically. So what you write on the next line is limit Don't forget the equal sign. N approaching infinity, 3n cubed divided by n cubed. Okay, we are not declaring that the formula in the green box is the same as the formula in this maroon box. These two formulas are not the same. We're not saying that. What we're saying is the two limit problems will have the same result. So we've been asked to find the value for this limit. As is, that's too complicated. So using this idea of comparing terms that add, right here, we can create a brand new limit problem that is much simpler. So we have created a new limit problem that will have the same answer, but they are different limit problems. Questions? Sweet. Okay, now we're on to this one. We've done the comparing, so now we want to see if we can factor and divide. Okay? You have a flashcard that says this. Only divide if the numerator and denominator are factored and you are dividing factors. So there are exceptions to this rule, but in our class, we're always going to follow the rule. Like we don't ever divide unless we are dividing, if the numerator and denominator are factored and we're dividing factors. So right here, we have changed the situation. In the green box here, the numerator was made up of two terms that are adding. In the maroon box, the numerator is made up of four factors that are multiplying. And then similar in the bottom. Questions? So now we're in a good spot because we can do this thing. We can factor and divide. Okay, the next step that I'm going to write, I want you to write it in your notes. You probably won't write this every single time. We're just doing it once or twice to make sure you're understanding what's really happening. So this becomes, I hate when the phone rings. It's okay. Now they get to be on the video. That's cool. Hi, this is Craig. Yes. Okay. Oh, very good. Okay. Bye. Soraya, you have to go to the library to get your Chromebook, so just run down real fast. What's that? Yes. We'll hope they don't call back. I understand. I'm on your side. I hate when they interrupt class. It drives me crazy. So, we'll just proceed. Okay. Okay. Now what you want to write is this: limit as n approaches infinity. Really what we have here is the numerator is, we've got like 3 over 1, and then we've got n divided by n, n divided by n, and n divided by n. Questions? That's what we mean by we have factors that are being multiplied. And now we can divide factors. Oh, please, Luke. You don't have to write this out for the test. Yeah, this is just me making sure you understand what's really happening. Good question. Anybody else? Oh, please, Chris. We'll see an example like that. What you would end up with is this item here would just be 1 over n. Because one of, the top and the bottom wouldn't have the extra n. Does that make sense? Yep. Okay, there's a sign here to remind you of something that I think is very important. In math, everyone says cancel. Like every teacher on the planet says cancel. Science teachers, they all say cancel. I'm the only one apparently who never says cancel, or very rarely, because I hate the word. Okay? When students say cancel, most of the time they have no idea what's happening. They just think drawing lines through things is mathematical. See, Soraya's laughing because she knows it's true. Like you just go, hey, draw a line through it. Cancels. Isn't that great? No. Look, nothing cancels. It changes. What really happens here is You recognize it does not matter how large n becomes. It won't matter how large n becomes. Something divided by itself is always equal to 1. So we don't cancel anything. We divide to make 1. Now, there's no canceling. I got in trouble from other teachers like, quit telling students that much. But it's true, there is no canceling. It divides to make 1. So I defended myself. Well, kind of myself. Whatever. I agree. Like if you really taught it that way from the very beginning, it would make so much more sense. And it would prevent so many mistakes. That's why I had you make this flashcard, is because people will cancel in many cases where it's completely illegal. This is wrong. No canceling, only dividing. And usually we're dividing to make 1. So, question. Awesome. Remember the signs, one of my favorites. Okay. Now look what happened. We started out trying to figure out, as n gets bigger and bigger and bigger, what's this green box going to equal for large values of n? That's pretty hard to calculate without like a computer. However, because we could use this compare terms that add idea, we were able to create a simple limit problem that's equivalent. Then we were able to factor and divide. Now we know easily, no matter how large n becomes, when n is large, this formula here in green is going to have a value equal to 3, or extremely really close to 3. It won't ever actually equal 3, because the other terms do have some effect. These terms here do have some effect. That effect is just very small. Emphasis on very small. Questions? Please. Listen to Maddie. It's important as you're going along that you tell the grader that here I'm still solving a limit problem. It's just a different limit problem. This one, as I said to Luke, we probably won't write that out much. We just did it today so you could see it. This one you just write equal 3 because you have found the limit. It's just 3. Yep. Oh, listen to Taryn. If you are working a problem, this won't happen in calculus, but if you were trying to say, okay, if I plug in a large value to this green formula, what do I get? You would have to say, I get approximately 3. But the limit is exactly 3. Do you hear the difference? Yeah, limit means don't tell me exactly what I'm going to get. What we're going to get infinitesimally close to equaling. Is that? Yeah, even better, Taryn, it's necessary. Like you do not want to put anything but equal. Because in terms of the limit, we are infinitesimally close to equaling 3. So I think you're good. Yes? Awesome. Please, Isaac. Correct. Mm-hmm. No, perfectly said, Isaac. Perfectly said. Literally, if we had it, I should probably build a little software thing and just show you that if you take this formula and you just keep plugging in bigger and bigger values of 3, you'll watch that output never equal 3, but it just gets closer and closer. I need to make that little spreadsheet because that's a really good question, Isaac. Easily done. So cool. I'll just make that and then you can see it. Anybody else? Cool. Okay. Oh yeah, please, Luke. Sorry. Let me see if I can say it back to you in a way, Luke, that will make sense. It goes back to what, so you and Taryn are exactly on the same page, exactly where you want to be. If you are computing this formula for larger and larger values of n, I guarantee those other terms do make a difference. But what you'd see with a spreadsheet is you'd see that that difference becomes less and less and less as n gets bigger and bigger and bigger. It is. And the analogy is even bigger. Like they make such a small difference that in terms of a limit, they can be ignored. It's not the best answer in the world. I'm not really, like the best way to show you to where you'd be comfortable, honestly, is to build like an Excel spreadsheet. And then I can show you two columns, like here's n getting bigger, here's what's happening to the formula, and you can see for yourself that, oh yeah, that is interesting, that the term here is so much larger than the other, that even though I'm adding something, I kind of start losing track that I'm adding anything. Does that kind of help? Okay, another one I like is this one. Sorry, you got me on the, that's the OCD thing kicking in. The weight of the earth. So just say yes or no. Look at me. If you take the mass of the earth and you add to that mass 1 grain of sand, just say yes or no. Did the entire mass increase? Yes or no? Yup is the right answer. Okay? The mass went up, but by such a small amount that you can't even hardly notice that it went up. Okay? The curvature of the earth is the same way. You don't walk outside and say, yeah, I can see the curvature. It's too big, right? Looks pretty flat to me. Okay, so anyway, moving on. Questions? Awesome. Okay, we've done this. We have found the limit as specified. The limit is 3. In your homework, you now have to do something else. You have to go determine if the given function has a horizontal asymptote or not. Okay, first thing you should look at is one of those 4 flashcards. You should look at the flashcard that says, finding a horizontal asymptote is exactly the same thing as finding the limit as x approaches positive or negative infinity. So in your homework, you have done the first part. You have found the limit as specified. We still need to determine if the function has a horizontal asymptote or not. So now we're looking here. How do we find a horizontal asymptote? Hey, coincidence. We actually find the limit as x approaches infinity. So we have done most of what the homework is asking. We have found the specified limit to be 3, but because that was the limit as n approached infinity, we can write this on our paper. We can say as n approaches infinity, the y value is also going to approach 3. We need to kind of think about what's happening as n approaches negative infinity. What's y going to do? Well, questions to that point? Okay, if n is approaching negative infinity, with power functions, the comparison does not change at all. This will still be dominant over this. It's back to that example I tried to give of the negative trillion versus positive million. The positive and negative doesn't make any difference. The much larger negative number is still more dominant than the large positive number. So if we were to find the limit as n approached negative infinity, we would have ended up with exactly the same result. Docking my paycheck for not sending Soraya down, but it's okay. Just kidding. Honestly, another point for you, Soraya. I love the fact that, sorry, I hate when they pull you out of class. I will take the hit. It's not that anyway, so anyway. Sorry, losing focus. Focus back on me. When finding the limit as n approaches positive infinity with power functions, the same results when we do negative infinity. So you don't have to do any analysis. You can just say, oh, that's going to be 3 as well. Therefore, here's the little symbol for therefore. Don't recall if I showed you that in class or not. There is a horizontal asymptote at y equal 3. Now we have completed what's required for the homework problem. Just a symbol for therefore, and that's a legal symbol on the AP test, so I like using it. I'm not sure it's any faster than just spelling it out, but for whatever reason, I seems less work. So, question? Yeah, that's fine as well. Yep. Please. Gotcha. I was searching for your name, Hannah Bartholomew. Okay. Um, what we did, Hannah, I just did it very quickly, so let's just go through it again. I would have come up here and said, okay, if n is approaching negative infinity, which term in the numerator will dominate? So here are my two terms of the numerator. If n is getting very, 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 very negative, this term, because it's cubed, will get very, very negative. There's a negative here, so this term will become positive. But the third power will make this term so much more negative that it will overwhelm this positive term. So this will be the dominant term, which means if I'm finding the limit as n approaches negative infinity, I'm going to get exactly the same result here. So no difference. So that's why I was able to say it won't matter if n is approaching positive infinity, Hannah, versus n approaching negative infinity. In both situations, this formula is going to end up having a value that, as I said to Luke, is not equal to 3, but is extremely close to equaling 3. Is that your question? It's good work, Hannah. Please. If I were to rewrite it, it would look like this. The limit, as n approaches negative infinity, we don't change what the term looks like, Riley. It just changes what we're ultimately computing, but there actually is no change. It's kind of weird. Like you're seeing it. Like when n was approaching positive infinity, we had this situation, yes? With n approaching negative infinity, we're still going to have this situation. What will change is n approaching positive infinity will have like 1,000,000 divided by 1,000,000, that's 1. Here we'll have negative 1,000,000 divided by negative 1,000,000, still 1. Does that answer your question? Good work. Anybody else? Cool. That's what you're going to do on 21 problems in the homework. Is you find the limit as specified, then you identify horizontal asymptotes. This, of course, took a while because we're trying to make sure everybody's clear on the why of everything. I can show you calculus problems pretty quickly. Like it doesn't take very long to say, hey, just do this, just do this, just do this. You would memorize it, you'd know how to do that problem, then you'd all fail the AP test. Okay, I'm not kidding. Like you would just read the test question and go, what? We didn't learn any of this. Because they're not asking you to copy. They're asking you to understand. And so we just have to keep doing exactly what you're doing. You just got to keep digging for understanding. Questions? Let's do another one. Cool. So, go here. Clear. Yeah, write that on your paper. These are just the same notes again. You don't need to keep writing those. I just put those there so I can reference them. You can just blame me, Soraya. You can say, he was going to send me down, he said, but then he got distracted and then he forgot to send me. So that's not the whole truth, but it's kind of the truth. So I don't like lying. It makes me nervous, but I just don't want you to get in trouble. How come you didn't come earlier? Like, Mr. Smith's fault. So I will take the fall for you, Soraya, anytime. So anybody else? Cool. Careful, strawberries. I like the box. That's awesome. I'm loving that. Give me one of those, Rachel. That's a good box. Sweet, man. Okay, I distracted you. Come back, John. All right. I like the video. That was awesome. I kept jumping in. It was cool. Never mind. All right. Focus. Talking to me, not you. Okay. You have to do two things on every single homework problem. So now we're back to, we've got to find the limit as specified. But because we're finding a limit as x approaches infinity, and because we're only dealing with power functions, it ends up being the same thing. Like when we find the limit, we will also be finding the horizontal asymptote. That's why I specifically had you make this flashcard. If I could show you past years, you would be astounded as to how many students forget this and will miss questions on tests simply for forgetting that flashcard. That's why you're making it this year, to prevent that from happening. Okay? Question. So go back to here. Remember, it says compare terms that add. So you have to look at the terms that are adding. So raise your hand if you can tell me, what are the terms that are adding in the numerator? Come on, it's not hard, just hands up. What are the terms that are being added together in the numerator? Kate in the back, here we go. Listen carefully what she said. It's really important that you not forget the negative. The numerator is x squared plus negative 4. How many got it? Point. Raise your hand. Which is dominant? It's not hard. Come on. Just want you interacting. It's way better if you interact. Rachel, what is it? How many knew it? Point. Cool. So x squared is dominant. So you're going to write an equal sign to show the grader that you understand what equal means. You have to use equal. You don't use equal on the AP test. It's like writing an essay with no periods. On an AP test essay, you would get no points. So don't do that. So limit as x approaches infinity, the dominant term in the numerator will be x squared. Raise your hand, please, if you can tell me the dominant term in the denominator. Hands up. Which term will be dominant in the denominator? Let's go, Amelia. Love how you said negative 4x squared. How many said what Amelia said? Nobody said anything with a point. You knew what I meant. Okay. I should have said, how many thought what Amelia said? That sounds awkward. Questions? Cool. Okay, now we're on to this step. We have done the comparison. Now we want to factor and divide if possible. So I write equal. Okay, this item that I'm now writing in blue, you do not have to write on your paper if you don't want to. I write it out because I have seen many, many students who just struggle to get that dividing concept done correctly. So what I see is this. I see the limit as x approaches infinity of 1 divided by negative 4 multiplied by an x squared divided by x squared. It is now clear to me that it is irrelevant as to how large x will become. That green box will equal 1. Now remember, this only works when x is getting bigger and bigger and bigger. If we were trying to analyze what's happening when x is getting close to, say, 5, this idea is not valid. So this idea in blue here, comparing, that only works if you're going to infinity. Chris, please. Either way. Either way. Another point for Chris. That's 2 questions. I'll eventually stop reminding you that every time I say your name, you can mark down a point. I just want you to pick up the habit. So. Awesome. Okay, so it doesn't matter how large x becomes. If we allow x to grow forever, we will see, like if we made an Excel spreadsheet, that this formula right here, this is the y. This is why. Okay, this is the understanding you're trying to gain. Like, don't lose track of what you're doing. Don't get lost in the steps. Okay, that's how they trick you. This formula is going to have a value, they said to Taryn, that will not actually ever equal negative 1/4, but the limit is declared to be exactly negative 1/4. So the value of the green formula doesn't equal negative 1/4, but the limit does. So, questions? Outstanding. All right, next one. Picking up some speed here. That one, oh wait a minute, let's finish the problem. My bad. We found the limit. We still need to make sure we talk about the horizontal asymptote. But as I said, because it's a power function, oh please, Hannah. Oh, good question. No. You're doing great, Hannah. Don't stop asking. Don't stop asking. You're exactly in the right place. And Taryn actually did answer the question correctly. Anytime we're trying to find a limit, we would next look here, just like Hannah said, to try and find the left and right limits. However, because x is approaching infinity, that one's unnecessary. There is no way, like, think of it this, like x approaching infinity, Hannah, just means x gets larger and larger and larger. It's not approaching a number. So we can't go at it from two sides. We just let it grow forever. So this step on your flashcard, don't forget it. Like, you're still going to need that for other problems, but when x is approaching infinity, you don't need it. Did that answer it? Okay, good job, Hannah. And Taryn. Anybody else? Awesome. Okay, don't forget, in the homework, you've got to do both things. We have found the limit. Now you've got to declare the horizontal asymptote. But because it was x approaching infinity, and because we were dealing solely with power functions, that's hinting that we eventually will deal with other things, but not yet, the horizontal asymptote's easy. You just write it down. Horizontal asymptote at y equals negative 1/4. And when you look in the back, you'll see it says, as x approaches infinity, this is Taryn's comment again, y is approaching negative 1/4. As x approaches negative infinity, because we have a power function, the result is the same. Y will also approach negative 1/4. Good question, Chris. I put this in the answers in the back. Don't leave yet. Don't leave. I got to say one thing before you walk out. I put that in the back so you understand how I'm thinking. Because again, how I think is the most important part. What I really care, Chris, is you're good at identifying the horizontal asymptote. So just make sure you're getting that right. Does that make sense? Kind of. I'm going to have to spend more time to answer that better, though. Okay, everybody look at me. Don't leave. Just really quick. Look. Really fast. Okay. The most important thing in this class is to do exactly what you all did today. Like, you keep asking questions, you stay very focused, and you keep probing to understand. Okay? Sometimes what happens is we spend so much time trying to understand, we aren't really far enough along to say it's fair to give you homework problems. Like, I don't want to get you home frustrated because we just didn't talk enough. There's more to learn. So don't do any homework yet. Understand? It's not a reward or anything. It's like I get that you get a little bit of a day off. The important thing is you just have to keep asking. Like, you can't succeed in this class if you stop asking. So if I say, oh, good luck, it kind of prevents you from asking. Does that make sense? So yeah, don't do any homework yet. So good job, you guys. Rachel, hold on. I don't know. That's written incorrectly. Yeah, I wrote it wrong. Sorry, Rachel. Yeah, that should be negative 1/4. I just wrote it wrong because I was in a hurry. Thank you, Rachel. Yeah, that was miswritten. I wrote negative 4. Rachel noticed negative 1/4. So good job, Taryn. Thank you, Rachel. Good job, you guys.